lesson on Venn diagrams and probability. So first of all, probability. So probability is, looking at chances something might occur. And probabilities are always going to be between 0 and, so we'll say P stands for probability, and 1. So 0 equals 0% chance, and 1 is equal to a 100% chance. So if you're looking at values and you get like the probability turns out to be like 2.4, that doesn't make any sense. Probabilities are always between 0 and 1. The probability of some event A is equal to the number of ways event A can happen divided by the number of ways anything can happen. So just know that, like, when you're looking at probability, you put the number of ways the specific thing can happen on the top divided by the number of ways anything can happen on the bottom. A Venn diagram is what we're going to talk about today. We can use a lot of different things, but a Venn diagram is one thing we can use. We can use a table, we can use a tree diagram, depending on the situation. But a Venn diagram is a way to compare things happening. So you've used them in English. You can compare and contrast different books or something in English. So if you have, book A and book B, one circle would represent book A, one circle would represent book B, and then the middle would represent them together, something like that. So let's look at, so when you think about it, like this part right here, that part right there is book A and book B. Maybe what they have in common. That's what that green highlight represents. That represents what book A and book B have in common. If you think about just this part, if we just think about that part right there, that right there just represents that part right there just represents book A. So if you think about that, that represents book A only. So it doesn't have to do with anything with book B. And if you think about this space right here, that space right there is just book B only, right? So maybe it's what is occurring in just book B. So anyway, that's how you might write some different similarities in a book in an English class. So we can do the same thing in math. So for example, let's say there are, let me pull this example first right here. So let's say we have this problem right over here, and on this problem over here, There's 28 total students. And 21 are female. And have an A in class. 2 students who are female, and 5 have an A in class, right? So that's the situation we have, and then there are 2 that are female and have an A. Okay? So if we wanted to represent this using a Venn diagram, what I'd do is I would say, okay, I got a circle for female, and we know that that total is 21. I got a circle over here for A in class, and I know that total is 5 according to this. So when I start to think about, and then I know the total students is 28. So when I start to write the different things in the different number of students in here in each place, I know there's 21, there's 2 females that have an A. So this space right here in the middle is 2, because that's the 2 students that are female and have an A in class. Well, what that means is there are 19 females over here that don't have an A in class that are still female. And there are 3 students over here that have an A in class, but they aren't female. So we can kind of figure out, well, okay, well, what do we have as far as this situation? If we think about the total students with 28, if you think about like the rest of this class, so if I think about the class in general, whoops, sorry, I'm going to do this in black. The class in general goes out here, right? And you know that this class has 28 students in it. Well, notice what we have in here. We have 19 plus another 5 more. So 19 plus 2 plus 3. That's 24. That means that there are 4 students out here that represent they don't have an A in class and they are not female, but they still are in the class. Notice that if we have all these, we have the 19 plus the 2 plus the 3 plus the extra 4. So that represents the whole class that we have representing this situation. So if I was going to answer this question, what is the probability that a student is a female given that they have an A in class? Let me not answer that question. So let's answer the question, what's the probability? So I'm going to write a couple of things on here. What's the probability that a student has an A in class? That would just be the 5 students that have an A in class out of the 28 students total. So that represents those students that are right there. What if I said, what's the probability as an A and is not female? Well, that's the 3 students that are in there out of the 28, because notice there's 3 students that have an A and are not female. They're right there because they still have an A. Okay? What if I said something like, probability the student is a female and not an A. So if a student is a female but not an A, that's the 19 out of the 28, because that's that 19 that represents right there. So that's how we're going to look at these probabilities here with this Venn diagram, where we can kind of take and we can cover up and we can get all of the things that might happen in here. So let me go through another example. So a lot of it is just writing down what the heck you have. So let's say I give you an example where I say 30 students, 17 play computer games, 10 play board games, and 9 play neither computer games nor board games. Okay. So if I think about what's happening on this, I got a circle that represents computer. Let me write that a little bit better for you. I got a circle that represents board games. And overall, I got this overall situation here that represents all the students. So if I think about what's happening here, I got the 30 students that are way out here. I got 9 of them that don't play anything. I know that the computer ones are 30, and I know the board games the computer games are 17. Sorry, computer game people are 17, and the board games are 10. Now, if I look at this, if I kind of go, okay, well, I know there's 30 students in here, but if I take the 17 plus the 10 plus the 9, I end up with too many, right? I end up with too many students, because that's 27 plus 9 more is 36, which means we have to have an overlap. Now, if we add the 17 plus the 10 plus the 9, that's too many. We're only supposed to have 30. That means we have 6 too many. So we're going to need to make sure we account for that. That means 6 students overlap in here. So we have 6 too many. So that represents the overlap. Okay, so that piece right there is the overlap. So that's the 6 students that represent that. Well, if there's 6 students right there, then you should see that there must be 11 students that just play computer games, and that must mean there are 4 students that just play board games. Now, if you look at the situation I have the 11 students plus the 6 students, that makes 17 for computer, plus the 4 extra, that's the 10 board games, the 6 and the 4, plus the 9, and that gets us to the 30. So that's what our Venn diagram needs to look like. So let's start answering some questions on this Venn diagram. Let's say that I want to say a student chosen at random from the group plays board games. So let's say, what's the probability board games? Well, that one's pretty easy. You know, we got the 10 out of the 30. So 10 out of 30 is what is perfect. That's exactly what we need. You know, that would be 1/3. Now, one of the things that you need to kind of know that 1/3 is equal to roughly 0.33 to 2 decimal places. It's really 0.33 repeating. So it's roughly equal to that, which is also the same as 33%. So we can write it any one of those. These are all the same way. So make sure on the Venn diagram, on the Desmos activity that you take note of that. Now the last thing that I want to maybe do is let me have let's do the probability a student plays board games but not computers. So if you play board games but not computers, notice that that grouping right there is going to be this part right here. Board games right here, but not computer games. Board games but not computer games would be right there. That would be the 4 out of the 30. Okay, so that would be the 4 out of the 30. Hopefully that makes sense. Take a look at that. I'll scroll up here. That's the key, is making that diagram right there. If you have questions, make sure you ask.